Marcraft is the new green energy, cybersecurity, and smart home development company for the iConnect training family. Marcraft has been in business for over 25 years, and we're renowned for developing world-class curriculum both on and offline, as well as instructor support materials that are comprehensive, student text and lab guides, as well as certification test preparation materials. The unit we're featuring here is our GT-9500. It's a wind and solar training unit, and it's one of 8 advanced level systems that we offer, which include solar, wind, fuel cell, hydro, biofuels, environmental monitoring, and energy auditing. We also have basic introductory level trainers, which include clean electrons, which introduce students to both fuel cells, wind, and solar training systems. And we have a sustainability training system as well, which teaches students about green design, construction, CAD, as well as using non-utility bearing materials. The GT-9500 is essentially a tabletop training system in which we've taken the real world environment and condensed it down into a classroom setting. So all of the components you see on the training system are what the technician will experience and see in real life. Now, of course, in a classroom setting, we can't rely on the wind or the sun to be available. So we have a light kit that powers the solar panels, which are mounted to the back of the unit. And we have a motor and control system or drill, which powers the 2 400-watt wind turbines. What we're teaching the technician here is how to install, configure, and design a residential training unit that will provide both wind and solar power to their residential system. We start with the diversion load controller, which will take the power that's being generated by either the wind turbines or the solar panels. This will then take the energy and store it down to batteries, which are included with the system. They're 4 12-volt, 7-amp batteries. Once the batteries have been generated and completely full, we have a diverter load light, which will take the excess power and turn it into a power that will be diverted to light this bulb. We don't want the batteries to be overcharged, otherwise it could damage the batteries. But this could be any sort of load-bearing device, including a water pump or a heat pump as well. So once they've learned how the load controller works and how the power is being diverted to the batteries or to the load light, they learn how an inverter works. And the purpose of an inverter is to take DC power and turn it into AC and create a sine wave that will make it compatible to go into the load center here. So the load center is the box that connects to your utility and then provides power to your house. The idea here is for the technician to make the customer understand what sort of array they're going to need to provide for that customer to either reduce their utility bill, to be able to run at what we call net zero, which means they don't have a utility bill at all, or if they want to put in a system that's fairly substantial, they actually can power their whole residence as well as put power back into the grid. Now, by putting power back into the grid, they actually will get paid by the government based on the kilowatts that they put into the grid every year.